All right, y'all. So let's see. This is 6.1, the set of rational numbers. So y'all, when I was in my class earlier, I forgot to hit record. So I'm making this video again. It's just me here by myself, okay, in the classroom. Excuse me. So there's not going to be any responses because it's just me here. Okay, so the set of rational numbers. Rational numbers, y'all, are fractions, okay? So we're going to be dealing with fractions for chapter 6, y'all. I'm going to kind of skip over right here where it says frequently. It is only in the upper grades of middle school that students begin to use integers for the parts of rational numbers. What they mean by that, y'all, is that they're going to start using like negative values. But it says prospective teachers should know to recognize that rational numbers can be negative as well as positive or zero. Okay, so what we're going to have here, you all, oops, let me get rid of this right here. Okay, what we have right here is ways that we can express our fractions. I'm just going to look at the first three because in your homework you don't have anything with probability, at least not yet. But a division problem or a solution to a multiplication problem. It says the solution to 2x equals 3 is x is equal to 3 over 2. Okay, because this really means 2 times x, so we have to do the opposite, which is to divide, and that's how we get our 3 over 2. Okay, a portion or a part of a whole. So again, a fraction, y'all, it says Joe received half of Mary's salary each month for alimony. And a ratio of Republicans to Democrats on a Senate committee is 3 to 5. In a ratio, y'all, we're always going to see that word 2. Okay. So let's look at our first problem here. It says, write a sentence that illustrates the use of 8 over 9 in each of the following ways. Okay, the first one is a division problem. So y'all, I'm trying to get 8 over 9. And since we're going to do a division problem, I want you to look up here at the first one. A division problem or a solution to a multiplication equation is 2x equals 3 is 3 halves. And so if I have 8 over 9, I'm looking for an equation that looks like this. 9x equals 8 because if I were to divide both sides by 9, I would get 8 over 9, right? So I'm looking for an equation that looks like this. And that looks like choice D, right? Okay. Part B says part of a whole. Remember, y'all, as a part of a whole, we're going to see the fraction somewhere. Okay, we're looking for the fraction 8 over 9. So I'm going to look at the problem here, and I want to see, okay, which one has a fraction of 8 over 9? That would be part A, right? Jane ate 8/9 of the pizza. Okay. And then part C says as a ratio. So y'all, in a ratio, remember the word I'm looking for is 2. Okay, TO. So as a ratio, let's see here, we're looking for the fraction 8 over 9. So I want to see 8 to 9. So the first part says the ratio of boys to girls is 9 to 8. No, but the ratio of boys to girls is 8 to 9. That's the one I'm looking for, okay? All right, let me keep moving along here. Okay, so it says for parts A through D, write a fraction to approximate the shaded area of the part as a whole. Okay, y'all, when I was doing these problems, before I came to class, I was looking at the picture, and usually when we have a picture, we want to think of the picture being cut up into equal pieces. So I have 3 rectangles here, 1, 2, 3. But the bottom rectangle is pretty big. But if we were to cut that rectangle, if I were to continue with that line, now I have 4 equal pieces, right? We got 4 equal pieces, one of them which is shaded, so that would be 1/4, okay? I'm going to use the same idea, y'all, for part B. So when I look at part B, yeah, they're not cut up in equal pieces. But if I were to do this, right, like that, like this, like this, like this, and like this, and then maybe come back over here and say, you know what, I don't really want that. I don't really want it to look like that, or like that, or like that. Now we might say, look, we have 1, 2, 3, 4, 5, 6, 7, 8 equal pieces, one of which is shaded, okay? With my circle, y'all, my circle is cut up into 4 equal pieces, 2 of which are shaded. Now, they do want us to write a simplified fraction. If I look at that picture, y'all, I can say, look, this circle is cut in half, cut into 2 pieces, one of which is shaded, so that would be a half, okay? And finally, part D. is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got 12 little circles, and 1, 2, 3, 4, 5 of them are shaded. Okay. All right, let me keep moving along here. So equivalent or equal fractions. Okay, so y'all, I'm going to kind of do this visually looking at the problems here, and I'm going to look at kind of the first two right now. So in the first one, y'all, we have a square. We cut that square into 3 equal pieces, and we shaded one of them. That's when we have our 1/3. Okay, all they're saying is for the second square, suppose we looked at that same square that we had before, right? 1, 2, 3, one of which is shaded, but they said, look, let's cut each of those thirds into halves. So now we have a square that's cut up into 6 equal pieces, 2 of which are shaded, but it's still 1/3, right? And they kind of did the same idea over here. Okay. This is what we call the fundamental law of fractions. Okay. So y'all, for this first problem here, it says, write for each of the following squares, write a fraction to describe the shaded portion. Okay. I got a square cut into 4 equal pieces, one of which is shaded. Okay. Now for part B, I'm going to zoom out because my answer part for part B is all the way down here. I have 1, 2, 3, 4, 5, 6, 7, 8. We have a square cut into 8 equal pieces, 2 of which are shaded, but it's still 1/4 of the big square, right? Y'all, part C, same idea. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 ladybugs at the ladybug picnic. I don't know if y'all remember that from Sesame Street. But anywho, we have 3 out of the 12, which again is 1/4. And finally, y'all, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And 4 of which are shaded, which is again still 1/4, right? Now the question says, what property of fractions does this illustrate? This is what we call the fundamental law of fractions. Okay. All right. So going on to the next problem, it says, based on my visual observations, would the shaded portion in the figure represent the indicated fraction? If not, tell why. So they're asking me, is that fraction, did we cut it into 4 equal pieces, excuse me, and shade 1/4 of it? Well, I know it's not cut up into 4 equal pieces, but we could cut it up into 4 equal pieces. But the question is, are we still shading a fourth? And that's kind of hard to tell, y'all. So I would actually go with part A. No, the parts don't necessarily have equal sizes, and it's possible that it's 1/4, but it doesn't necessarily indicate it for certain. Okay. Now, when I look at part B, you might say, well, look, they're not cut up into 4 equal pieces, but let's go slow. If I have my square here, and we cut that in half, and we cut that in half, now that's 1/4, and that's 1/4, right? And we cut this one in half, but we just cut it this way, and that's another 1/4. So yeah, that's really 3/4 of my fraction. Okay. And part C, did we shade half the circle? Yes, we did, right? The circle is kind of like a little yin and yang, but yeah, we still have half of that circle being shaded. Okay. So let me keep moving on here. Okay, the next problem here, y'all, says use the Venn diagram pictured with A representing the people in an art class, B representing the people in a botany class, to express the fraction of the elements in the indicated sets as part of the universal set. Okay, so I'm going to read this slowly. A is the number of people in an art class, B is the number of people in a botany class, and we're going to write fractions of the elements in the indicated sets as part of the universal set. So the universal set, y'all, is just going to be the total, okay? So I'm going to take my calculator here. Let me clear this out. What's 23 plus 6 plus 13 plus another 14? Total is 56 here, okay? So when I do part A intersection B is looking for the people who are both in art and botany, and that's 6 out of 56, okay? Now, y'all, we always want to reduce our fractions. So let me show you how I'm going to do this. I'm going to come back over here. I'm going to go to my, oh, here we go. I already opened it up earlier. My multiplication table, y'all. I want you to look at the 2's. 2, 4, 6, 8, 0, 2, 4, 6, 8, 0. They all end in either 0, 2, 4, 6, or 8, right? So I see that both these numbers end in a 6. That just tells me that we can divide them both by 2, okay? And half of 6 is 3, and half of 56 is 28. And y'all, if you think about, what did your classroom look like when you were in 3rd grade or 5th grade or whatever? Elementary school teachers have their own classroom. You have a bulletin board. So you might have like a really big, massive multiplication table on there. I would definitely do that so that I can show my students exactly what I'm looking for, okay? Now, part B. Part B says we're looking for the elements that are in A that are not in B. That's just that 23. 23 out of the total of 56. Y'all, I can't reduce this fraction, so I'm going to leave it as it is, okay? Part C says, let's take everybody in the universal set. How many is that? 56. Out of how much? 56. There's my 1. Okay. Okay, and then there is a part D. Now again, y'all, I know it's been a long time since we talked about Venn diagrams. That was probably in chapter 2. Okay, so this one right here says, let's look at the numbers in A intersection B. That was the number 6. We want all the numbers except for 6. Okay. So what numbers am I looking at? I'm looking at all the numbers except for 6, like 23, let me clear this out, 23 and 13 and 14, 50, right? Again, what would I tell my students? Look, y'all, we can divide them both by 2. That's 25 and that's 28, and that's where we would stop, okay? All righty. So let me keep moving along here, y'all. For the next part, it says find 3 fractions equal to 2 over 11. Enter the correct numerator to match the new denominator. Okay, y'all, if I was teaching this to kids, right, I would say, look, y'all, we're going to do something that I call stare and compare, okay? I'm going to look at my 11 and I'm going to look at my 44. And I'm going to say, what did I multiply 11 by to get 44? Hey, we multiplied that by 4. Well, if we do 4 times the bottom number, we got to do 4 times the top number. That's going to give me an 8. Okay. And I'm going to keep playing this game. And I'm going to say, look, 9 times 11 gives me 99. So 9 times 2 gives me 18. Okay. Again, 11 times what gives me 121? Again, I would use my multiplication table. Look right here, 11 times 11. Okay. So 11 times 11. So I got to do 11 times 2 is a 22. Okay. Now I'm going to keep playing the same game here, y'all. Now we just got a different fraction. Okay, but look, 11 times what is 44? We're going to multiply that by 4. So 4 times negative 5 is actually a negative 20. Okay. 11 times what is 99? 9. So 9 times negative 5 is actually a negative 45. Okay. And same thing for this next one. 11 times what is negative 55? A negative 5 here and a negative 5 there. That's a positive 25. Okay. And I'm playing the same sort of game here, y'all. So I'm going to say, look, 10 times what is 40? 10 times 4. So 4 times 0 is 0. 10 times what is 90? 9. So what's 9 times 0? Oh, that's still 0. Okay. 10 times what is 110? Times 11. And 11 times 0? Still 0, right? Okay. Now, same thing here, y'all. All we're doing now is that instead of having a number, we got a letter A. But I'm playing the same game. I'm saying, look, 2 times what gives me 4? 2 times 2. So 2 times A gives me a 2A. 2 times what is 16? 8. 8 times 2. So 8 times A is an 8A. And 20. 20 times 2. So 20 times A is a 20A. Okay. All right. Now, same sort of thing here, y'all. We're looking for the definition of a simplest form. All it means is we're going to reduce our fractions, okay? So just like I showed y'all before, look at the first one. 110 over 104. Oops, 104 more. Okay, look, we can divide them both by 2. So half of 10 is 55. Half of 104 is 52. And again, I can't reduce these anymore, so I'm going to stop right there. Okay. Part B, look, 20 over 28. Look, let's divide them both by 2. Okay. Half of 20 is 10. Half of 28 is 14. We can play that game again. We can divide them both by 2. That's 5 over 7, and we'll stop right there. Okay. Now, look, y'all, for 39, negative, and 91, again, use your chart, right? So look, here's 3 and 39 and 13 to give me 39. So I know I can divide 39 by both 3 and 13. But if I look further down, I see 91 over here too. That tells me I can divide both 39 and 91 both by 13. And 3 goes into 39 3 times, and 3 goes into 91 7 times, right? So for part C, I can say, look, we're dividing them really both by 13. That's a negative 3, and that is a positive 7. Okay. All right. So I'm going to keep moving along here, y'all. I'm going to hold off on part A. I'm going to come back and do part B right now. Okay, it says, which expression best describes 3 divided by 0? Before I do that, if I were to ask you, say, what's 24 divided by 6? I think we would all say 4. And if I said, well, why is it 4? Well, you would say 6 times 4 is going to give me 24, right? So look, if we were to do that, what's 3 divided by 0? Suppose you thought the answer was 3, okay? And I would ask you why. You'd say, well, 0 times 3 is going to give me, oh, wait. 0 times 3 gives me 0, not 3. So you're to say, oh, sir, I was just kidding. It's not 3. Maybe it's 7. Well, 0 times 7 is going to give me 0, not 3. Okay. So we would say, you know what number I have to put here? I have to put a 0 because 0 times 0 gives me, oh, that still doesn't give me 3, does it? Okay. So you know what? We would say, you know what? There's no number I can put there because 0 times anything is always going to give me 0 and it's not going to give me 3. This is what we call undefined because we cannot do it. Okay. So look, y'all, where is the 0? The 0 is on the bottom part. When the 0 is on the bottom part, it's undefined. When I come back to part A, it's on the bottom part. That's also going to be undefined, okay? Now, if I look at part C, let me clean this up a little bit. Okay, if I look at part C, the 0 is on the top. So 0 divided by 4, suppose I said this one was 0. Well, look, 4 times 0, yeah, that does give me 0. So it's okay for us to have 0 on the top. If we have 0 on the top, my answer is 0. If I have 0 on the bottom, it's undefined, okay? All right, so part D here, y'all, says, which expression best describes 2 plus a over a? Okay, so look, this is what I would say. Look, let's let a be, say, the number 3, okay? 2 plus 3, that would give me 5 over 3. I can't reduce that, so we're going to say this thing here can be simplified, okay? All right. Now, let's try this one here. I'm going to pick a different number for a. Let's pick, I don't know, a equals 1. 15 plus 1 is 16. 5 times 1 is 5. I can't simplify that either, so it can't be simplified, okay? Let's keep moving along. Okay, equality of fractions, y'all. Equality of fractions, just say 2 fractions are equal to each other if, when we cross multiply, those numbers are going to be the same, okay? Oops, sorry about that. Bring this, here we go, bring this back. Okay, if I want to know these 2 fractions are equal, I'm going to have to say, look, let me take 10 times 247, that's 2470, and let me take 13 times 120, I don't know what that is off the top of my head, 13 times 120, and I'm coming up with 1560, okay. If those numbers are equal, then the 2 fractions are equal, but those 2 numbers aren't equal, so we're going to say those 2 fractions are not equal, okay? Now, let's do part B. I'm going to do the same way. Look, y'all, I'm going to take 10 times 130. That's 1,300. I'm going to take 26 times 50. That's actually also 1,300. Since those two numbers are the same, we're going to say those fractions are equal. Okay. Because when we cross multiply, if we get the same answer, they're equal. If we don't get the same answer, then they are not equal. Okay. Let me keep moving along here, y'all. Okay, so for this next problem, it says draw an area model to show that 1/2 is equal to 2/4. Okay, so let me show you what I'm trying to do here, y'all. I'm going to back up here because I want to look at all my choices. Okay. The first one is 1/2. That means I want to look for a square that's cut up into two equal pieces, one of which is shaded. Well, it looks like A and D both have that. Okay. For the second part, though, I want to look for a square that's cut up into 4 equal pieces, 2 of which are shaded. That looks like D. So D looks like the answer that I'm going to pick here, y'all. Okay, based on the fractions that we have. Okay. All right, let's come back over here. Let's look at this next problem, and it says, a man filled his 32-gallon gas tank. Okay, and he took a trip and used 1/8 of the gas. Draw an arrow in the figure to the right to show what his gas gauge looked like after the trip. Okay, y'all, so when we look at our gas gauge here, what we're looking at is we're looking at the spaces in between the lines. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, if he used 1/8, then the line is going to be right there. Okay. Now it says how many gallons of gas were used? Well, we have 32 gallons, and we're going to cut that up into 8 equal pieces. Okay, so 8 equal pieces. Because he used one of them, he used 4 gallons. If he would have used 3 of them, I would just, 4 gallons and another 4 gallons and another 4 gallons, so on and so forth, right? But in this case, he used 4 gallons. Okay. All right, let me keep moving along here. Y'all, for this next problem here, it says, solve for x in each of the following. Okay, so they're telling me that the fractions are already equal. So what I'm going to do here, y'all, I'm actually going to cross multiply. So 3 times 17 equals 4 times x. Okay, so let's figure out what's 3 times 17. That is 51 equals 4 times x. So I'm going to divide everything by the number 4. And 4 does not go in nice into 51, y'all. So I'm going to just leave that as a 51 over 4, okay? Doesn't go in nice and pretty, so we'll leave it like that, okay? For part B, I'm going to do exactly the same thing. I'm going to cross multiply. So 2 times x equals whatever 3 times 14 is. I know it's a negative. We'll write the negative right now. Negative 42. Okay, we're going to divide both sides by a positive 2, and that is a minus 21. Okay. So, y'all, for the next problem, it says, for each of the following pairs of fractions, replace a comma with the correct symbol, either less than, equal, or greater than, to make a true statement. What we're trying to do is we're trying to compare those two fractions, okay? Y'all, what I want to do is I want to find the common denominator between 5 and 6. The way I would do this, I would use my multiplication table. Look, here's 5 and 6. Let's go down. The first number that they both have in common, y'all, is 30, okay? So look, I'm going to put a 30 here and a 30 here, okay? And I'm going to look, we used to have a 3/5. What did we multiply 5 by? Hey, we multiplied that by a 6. So that's really an 18, right? What did I multiply 6 by to get 30? Hey, I multiplied that by a 5. So I'm going to do the same thing with the top. That's a 25. Okay. Now that my numbers on the bottom are the same, y'all, we just got to look at the numbers on the top. Is 18 smaller, equal, or bigger than? Hey, 18 is smaller than, right? And that's how I would do this problem. Okay. Y'all, for part B, negative 8 over 9 and negative 3 over 4. I would do the same thing. I'd say, look, let's find a common denominator. Let's come back over here. Look, here's 9 and here's 4. And it looks like 36 is my common multiple, right? It's the first number that they both have in common. Okay. So look, we're going to multiply this guy by 4. So we're going to do that one by 4. That's a minus 32. We're going to multiply this one by 9 and this one by 9. That's a minus 27. Now, y'all, a lot of times people struggle with, well, what number is bigger or smaller, okay? So look, draw the number line, okay? Look, here's 0. I know these are positive numbers, and these are negative, right? Look, negative 27 would be somewhere here, and negative 32 would be this way. Negative 32 is actually smaller. Why? It's further away from 0. So that would be less than as well, okay? All right, let me keep scrolling along here, y'all. Okay, for the next problem here, it says, for each of the following, find two rational numbers between the given fractions, okay? 1 over 7 and 2 over 7. I want you to look at my answer choices, okay? So, y'all, this is what I'm going to do. I'm going to go 1 over 7 and 2 over 7. They're giving me fractions with denominators of 14 and denominators of 21, okay? So look, let's do it this way. Let's write fractions with denominators of 14. I know I got to multiply this one by 2 and that one by 2, and the same thing over here. So 2 times 7 is 14, 2 and 2 is 4, 2 and 7 is 14, 2 and 1 is 2. Now, I'm looking for two numbers between those two fractions. Well, guys, between 2 and 4, there's only one number, and that's 3 over 14, but I need to get 2. Okay, so look, let's try this again. Let's look at the two fractions that we have, 1 over 7 and 2 over 7. And let's write denominators with 21, okay? So look, if I multiply that by 3, I got to do that by 3. And if I multiply this by 3, I got to multiply that by 3. Okay, so I have 3 over 21 and 6 over 21. What numbers are between 3 and 6? 4 and 5, right? 4 and 5 over what number? Over 21, because that's the denominator that I have, okay? All right. I'm going to do the same thing for this next problem, y'all. And I'm going to cheat a little bit. Not really cheat, but I'm going to skip ahead to 27, okay? So look, if I multiply this one here by 9 and that one there by 9, and the same thing here, right? Look, let's take a look. Oh, wait, not by 9. I don't want to get 27s. I don't even have 27s. Oops. What denominators do we have? We have denominators of 9. I think that's what I was thinking of. I want to get denominators of 9. So I'm going to multiply those by 3 and this one here by 3. Okay, that's a negative 3. That's a negative 6. What two numbers are between negative 3 and negative 6? What about negative 4 and negative 5, right? All over what? Over 9. Okay. All right, y'all. So we did a problem kind of like this before. Again, what I'm going to do is I'm going to get rid of that little piece and that little piece and that little piece. And I'm going to say, look, here's my rectangle. It's cut up into 6 equal pieces. How many are shaded? 1 out of the 6. Okay. All right. Now, for this next problem here, y'all, it says arrange each of the following in decreasing order. Okay, so look, for part A, again, this is probably more of a 6th or 7th grade problem, y'all. The way I would do this is I'm going to say, look, I want to find my common denominator. It doesn't have to be the lowest common denominator. But one way I could find a common denominator is by taking those numbers, 11 times 15 times 17. Okay, so look, let me try that. 11 times 15 times 17. That is 2,805. Same thing here, 2,805, 2,805, okay? All right, that's my new denominator, okay? Now look what we used to have before. We used to have an 8, right? Now on the bottom, we had an 11 already, right? But what numbers did I have to multiply it by? Well, 15 and 17. So I'm going to put that 15 and 17 right there as well, right? Because I already had the number 11, okay? Now, in the next one here, same thing, y'all, 11, 15, and 17. I already had the 15, okay? I have an 8 on the top. What numbers did I have to bring in? The 11 and the 17, okay? And the same thing for the last fraction. Look, we already had an 8. We already had a 17. Oops. 11, 15, and 17. We already had the 17. Those were the ones that we had to bring in. What I want to do is I want to figure out what each of those numbers are on the tops, okay? So look, 8 times 15 times 17, that number is 2040, okay? Let's do it again. 8 times 11 times 17, that number is a 1496. And then finally, 8 times 11 times 15, that is a 1320, okay? Y'all, they want to do this in decreasing order, meaning we're going to go from the biggest number to the smallest number. Since my denominators are all the same, are these numbers going from bigger to smaller? Yes, they are. So we're already in the right order, okay? Look, y'all, I'm going to do part B. I'm going to do it exactly the same way, okay? So look, negative 23 over 25, negative 17 over 32, negative 1 over 5. Okay, my common denominator is going to be what I get when I multiply all the bottom parts together. 25 times 32 times 5, 4,000. Okay. Okay, so look, y'all, we really took 25 times 32 times 5, right? Now, upstairs, we already had a 23. Okay, downstairs, y'all, we already had the 25. These were the ones that I brought in extra. Okay, upstairs already had a negative 17. Remember, 25 and 32 and 5. We already had the 32. Those were the ones that we brought in extra, right? We got a negative 1 there. 25, 32, and 5. We already had the 5. These were the extra ones, that we brought in extra, right? 25 and 32. Okay, so let me multiply this out. 23 times 32 times 5, negative 3680, okay? 17 times 25 times 5 again, 2125. And finally, 25 times 32, negative 800. Okay, they are already in order, y'all, from biggest to smallest. So the order is already there, okay? All right. The next one here says, prove that any integer n can be written as a fraction. Oh, we can just go n over 1, okay? The next one here says, a typical ruler is marked in 1/16 of an inch, okay? 1/16 of an inch, y'all, this is all it means. We're counting the spaces in between. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so 3 over 8. But, y'all, they do this in 1/16. Okay, so if I multiply that by 2 and multiply that by 2, that would give me 6 over 16. So I want to know which one of those up there has 6 out of the 16. Well, look. 1, 2, 3, 4, 5, 6. No, okay, I know it's not that one. That's too much. I definitely know it's not that one and not that one. Maybe D. 1, 2, 3, 4, 5, 6. There we go. So D is my answer. And then finally, let's see. 10 light bulbs were in the chandelier. Half of the light bulbs were not shining. How many were not shining? 5. Okay. Again, y'all, so I had just forgotten to hit record earlier. So I did this. I kind of went a little quicker because I wasn't asking anybody here. But again, if y'all got any questions, please let me know, okay?